Welcome to our presentation about the basics of accounting information systems. This presentation will cover the material that I will worry about from the first 4 chapters of Bodner and Hopwood, abbreviated BH, on your syllabus. These 4 chapters contain most of the information that you would need for the CPA exam. So you've obviously had more information if you've taken an accounting information systems course. That's okay, because that extra information prepares you for your career. So again, my goal is to give you enough to get you through most of what would be on the CPA exam. I do have other chapters on the syllabus. Simply read them as background information. These first 4 chapters in this handout would be all the information I would test you on. So let's take a look here at Chapter 1, an overview of AIS. So you should have this handout in front of you. It's on Canvas for you. So a little introduction. First of all, what is an accounting information system? Well, it's a collection of resources to input or capture, also transform, store, and then output data. And the output results in the transformation of data into useful information. So data by itself is not very useful, but run through an accounting information system, it will be. And this may be compiled into reports. And an AIS, or accounting information system, includes people, equipment or hardware, procedures, possibly software, most likely software, and the functions are essentially the same in both manual and computerized environments. So that's why I say possibly software. There are still small companies using an exclusively manual system or something very close to it. So first of all, an information system. That's the use of information technology, or IT, to provide information to users. So a computer is there. And specifically a computer-based information system, which uses computers more extensively, uses computer hardware and software. We're going to assume that we're dealing with a computer-based information system unless we're told otherwise. So that is our default. Then, also in CPA exam, they will also test us on different types of information systems. So one type of information system, you've heard this term, is EDP, or electronic data processing. And it's the use of a computer-based information system to perform transaction-oriented data processing. In other words, recording transactions and then processing them. And it's also referred to as a transaction processing system in an accounting context. So as you can see, a lot of what we're studying here in this chapter is terminology, and that's okay because it is tested on the CPA exam. So it's quite straightforward. Then if we go up in terms of scale, we could have a management information system, or MIS, and that provides decision-oriented information to management. So it is more sophisticated. And commonly, these are for marketing, manufacturing, human resources, accounting and finance, may also be for customer relations management or supply chain management, including materials requirements planning, or MRP, where we're deciding when to buy materials and getting assistance in placing that order with the vendor. Then, if we come up another notch in terms of sophistication, we have a decision support system, and that provides information in a decision-making format for the user. Come up again in terms of sophistication, an expert system. And an expert system is a knowledge-based information system which acts as a type of consultant to the user. It requires decision models and specialized databases as knowledge bases, and is characterized by the use of heuristics, or some rather simple decision rules. Then, more sophisticated still, would be an executive information system. That's for the needs of top management. Then we defined an accounting information system above. More sophisticated still would be an enterprise resource planning system, or an ERP. Combines all the above under a single software package and a single database. And sometimes this creates additional problems, though, due to the degree of centralization here. So if the ERP has problems, it's centralized. All the other operations within the company do too. So thus, this process of centralization is a double-edged sword. some good points, some bad points. And the re-engineering, or thinking everything back through, required to implement an ERP usually improves business processes. For example, when Publix several years ago went to the world's most common ERP system, which is SAP, that's a German company, they had SAP employees out there for over a year. So quite sophisticated. Then the next wave will be employing artificial intelligence to help with ERPs. That's already underway, so we'll see what happens in the next few years. Now let's see some additional possible features of accounting information system. Well, end user computing is the hands-on use of computers by end users to perform the required functions. That's expanded over the years. So the computer on someone's desk can do a whole lot more than it used to, the employee being an end user. Then second, quick response technology is the ability of an accounting information system to respond quickly and accurately. Let's see some things with this. First of all, radio frequency ID, RFID. It's an application of quick response technology. And RFID tags are placed on objects to allow them to be tracked in real time. So if we think, for example, about a pet being chipped, that's an example of RFID. Or if we think about the rather simple RFID tag that is in certain products or on certain products that sounds the alarm as one goes out the store if it's not been deactivated, there's another example. And if RFID tags come down in cost, we'll see more information that's placed on RFID tags. For example, that will allow inventory to be taken with only a detector being run past inventory instead of having to manually count it. That would also allow products in a cart at the grocery store to be automatically scanned by a detector and rung up, and then there would not need to be an optical scan of them. Well then, point of sale technology controls sales either at the cash register or other origination point. So point of sale technology, we could think of barcodes here. Then lean manufacturing, that term. What it attempts to do is to eliminate waste and streamline production flow. And it's based on the Toyota production system, requires much quick response technology because one must have information in real time, or in other words, instantaneously. And the Toyota production system is something that we studied about in managerial and cost accounting. And also in managerial accounting and cost accounting, we studied about just-in-time systems. They produce and or purchase inventory just in time to use it or sell it. And the goal is to reduce inventory stockpiles and save inventory carrying costs. And current sales create demand pulls. So it all starts with a sale. A customer wants something, then everything previous in the manufacturing system is pulled. And those generate orders for inventory, such as for direct materials. And these can be automatically generated given a good accounting information system. Well then, number 3, web commerce to sell via the internet. This requires the use of intelligent web-based software. And the transactions are normally encrypted to enhance security. Security can be increased by issuing passwords to authorized users, and there should be a firewall between the customer and internally stored data. Now, it's not very popular, but CPAs can provide an assurance service which yields a web trust seal of approval. We've all dealt with web-based commerce because we've all purchased things over the internet. Then, an old term actually starting in the 60s is electronic data interchange, or EDI. It's the direct computer-to-computer exchange of business documents via a communications network. Relies on information to be in specific fields in the documents as well as other specific protocols. That was back when computers were not as sophisticated certainly as today, and it was based on the old COBOL language. Today, EDI is used as sort of a buzzword for any electronic commerce. Then, we should also know extensible markup language, just as a term, XML. It's a major improvement over traditional ETI protocols and allows data, excuse me, to be arranged in databases and to be tagged with identifiers. And then if we bump up a notch from there, Extensible Business Reporting Language, or XBRL. It's a form, pardon me if you have a typo there with "and." Go ahead and take care of that. Which is for financial reports that allow specific items to be tagged with identifiers. It was developed by an AICPA-led group. In fact, IFRS, International Financial Reporting Standards, makes use of XBRL, and this way, readers of financial statements can use a computer and treat the financial statements like a relational database and drill down there, for example, to automatically generate some financial ratios if they would like. And then electronic funds transfer, or EFT systems. Those are for the electronic movement of funds. So if you pay bills electronically, you're using EFT. Now, indeed, some risks of an accounting information system. First of all, transaction trails can be very volatile, so they evaporate. We can't trace them sometimes unless we exert an effort to and document things in our system. So these trails, they may exist only for a short time, or they may not be readable by humans. And this prevents a viable audit trail. So we can't trace them sometimes. And that's especially true in real-time systems because data are entered directly onto the computer. By the way, data is a plural term. And if we want it really, really true, well, true in online transaction processing because databases are updated immediately when transactions are entered. And batch systems tend to maintain a better trail of documentation. That's where we wait to record transactions until we have a bunch of them or a batch of them, in other words. So they're not recorded in real time, they're recorded later. And that does give a better transaction trail. Now, number 2, a computer processes transactions uniformly by using the same processing instructions. And that's normally a major strength as there is consistent application of predefined rules and the performance of complex calculations in high volume. However, if there's a programming error or a similar systematic error in software, then all transactions will be processed incorrectly. So again, it's a double-edged sword. There's not the judgment there the humans have. Artificial intelligence is making some promises there to help remedy that. So again, we shall see. So speaking of human judgment, well, human judgment is reduced. Again, a double-edged sword. So this does have the advantage of reducing human error, but people often tend to overtrust computers. They believe they don't make mistakes, and that's very true. So they may not internally verify the results or transaction logs. They just don't tend to check things over sometimes. Then fourth, unauthorized access can be a major risk. In fact, one of the most important controls in an accounting information system is user authentication to make sure it's the right person. And an AIS must have strict firewalls to keep unauthorized users out, and also user ID and password combinations. Otherwise, an unauthorized user can access the system through a terminal or from anywhere in the world in a web-based system. In fact, at Florida Southern, our audit partner said a while back that if he wanted to get into our system, he would probably do so through the copier if he were a hacker. He wouldn't have to physically be in front of the copier, but he would hack into our information system through the copier since all of our computers in the building are connected to the copier. Then number 5, data must be protected. Data must be backed up and stored off premises. Data backup should also follow the son, father, grandfather principle. That means this: the son is today's record. The father is yesterday's record. The grandfather is the day before. So let's say that we somehow no longer have the son. Well, if we ran the father, that record or that database, and ran that with today's transactions, we could recreate the son. So it just refers generations. Well, then number 6, as we will often mention, computer systems combine some duties which should be segregated for good internal control. That's something that we covered in the first auditing course. And a related issue, the computer also authorizes many transactions. This automated authorization reduces human involvement, and authorization programs must be carefully coded. Otherwise, an unauthorized employee or even someone from the outside could get in and change the computer program. Not good. Then number 7, an accounting information system should have uninterrupted system availability because subject to disruptions due to electricity flow, environmental hazards, unauthorized changes in software or data files, and communication problems between devices. So let's say there's a hurricane, the power goes out. Well, we no longer have our computer usable. So trying to maintain power or other resources that we need, that can be a major problem. And then accounting information systems problems can be material internal control weaknesses and audits. In other words, something majorly wrong with internal control, and auditors get concerned. Then lastly, in this chapter, just some other information. First of all, information systems should be under the control of the organization's Chief Information Officer. CIO is the term for that, the acronym. And this should be separate from the accounting function, which should be under the Chief Financial Officer or CFO. We always want to segregate those duties. Then we should get input from accountants. They should assist in the development of the accounting information system. It's amazing how many times accountants have been left out of that process. Then C, the term systems analysis. It's the process of determining the information needs of the organization. Again, accountants should be there. Then D, systems design, is the process of formulating a blueprint or a plan for the information system. And then the term systems implementation involves actively carrying out the blueprint. So implementing that blueprint. And one extremely important function is systems documentation, in which everything is recorded accurately. And that's extremely important for computer programs. And it also helps with Sarbanes-Oxley compliance. It's required by the SASs. So as always, the mantra is document, document, document. That concludes chapter 1. Let's look at some information from chapter 2. If there's any information I don't mention, I will not test you on it. Simply read it as far as background material. So systems techniques and documentation. Again, document, document, document everything we can. Well, the first thing is flowcharting. And some of you have had flowcharting, some of you haven't. Sometimes some flowcharting symbols will appear on the CPA exam. So just to let you know, a flowchart is a symbolic diagram and provides a picture of the definition, analysis, or solution of a problem. And it presents a processing that the organization goes through sequentially, from the beginning to the final output. Processing usually flows from top to bottom and from left to right, just as we read. And flowcharts are important documents to understand, evaluate, and document internal control and information systems. So it's a major means of documentation. 3 different types of flowcharts. A system flowchart provides an overview of an information system. Then accountants don't deal too much with number 2, a program flowchart. That's for a computer program. That would be for a programmer. And number 3, accountants do deal with these, and this is the most likely thing to be on the CPA exam. A document flowchart shows the flow of documents through an organization. And areas of responsibility, such as accounts receivable, are usually shown in vertical columns. And then in the book, if you've not had flowcharting, you should know the basic flowcharting symbols, which are on pages 41 through 43, the logical data flow diagram symbols on page 47 and the additional symbols on page 51. Good for review. These things could be on the CPA exam. And also one could be on the CPA exam in C. You should carefully read the section on drawing a flow chart on pages 51 through 54. I think you'll be fine with those things on your own. If not, just ask me. I'll be happy to help. And speaking of documentation, here are some other methods of documentation. Well, first of all, we bear in mind the form and extent of documentation will be influenced by the nature and complexity of the controls. The more complex the controls, the more extensive the audit procedures, the more extensive the documentation is going to be. That would be the case, for example, in a large organization, whereas in a small organization, this would be much, much simpler. That also reflects internal control in general. Much more complex in a large organization, much simpler in a small one. Then, one method of documentation is a questionnaire. That's a series of interrelated questions about internal control policies and procedures. Auditors often use internal control questionnaires and let client personnel fill them out. It's a means of written documentation. So how'd you go about performing your job, for example? Then C, a narrative memorandum is a written description of the process and flow of the documents, of the control points, or the major places where we need to have good internal control in place. For example, the point of sale is always a major control point because many things can go wrong. Then D, just to know the term, a branching or decision table identifies the contingencies considered in the description of a problem and the appropriate actions to be taken in each case. Normally presented in matrix form. That's probably not too likely to be on the CPA exam. And finally, a checklist has a series of procedures to be performed. That concludes chapter 2. On to chapter 3. A little bit about e-business and e-commerce, E standing for electronic. So first of all, electronic business or e-business is use of information technology in any aspect of the organization. For example, on the internet, we use it all the time. And specifically for buying something or selling something perhaps, in B, electronic commerce or e-commerce is the exchange of products using e-business. And then web commerce is e-commerce specifically using the internet. Then D, some definitions. Electronic networks are groups of computers which are connected together electronically. These could be local area networks which span a single site. For example, one of the buildings on campus. Or we could have a metropolitan area network which spans a metropolitan area, or wide area networks which span at least 2 metropolitan areas. The internet is even a wider network. Thus, a local area network is smaller than a metropolitan area network, smaller than a wide area network, and smaller than the internet. So if we were to think on campus about Canvas, that would be another example of a local area network. Or if we thought about the single sign-on for Florida Southern, there we have it too. With metropolitan area networks and wide area networks, those are not used as extensively these days because they've largely been replaced by the internet. Then E, outgrowths of the internet are intranets and extranets. They're defined by who has access. An intranet is within one organization. So we could say, once again, the Canvas or the single sign-on Florida Southern would also be an example of an intranet. And some parts may be inaccessible by those outside to protect it. The more outside users one has, the more risk one has. Something could go wrong, could get hacked. An extranet permits 2 or more organizations to be linked together if they so choose. Then E, an information factory for the organization includes the following. First of all, operational databases. They store relatively current transaction data for quick access. Then a data warehouse. That stores enormous volumes of current and historical data for use in research and analysis. And this permits data mining, which involves identifying relationships between data and mapping such patterns. So data warehouse is very, very useful for research. Vast amounts of data and usually historical data, whereas an operational database is smaller and much more current in general. Then the process of moving data from outside sources into the data warehouse is called extract, transform, and load. For example, as marketers gather information about us as we use the internet, they are doing exactly this. They are taking our information and using ETL to load that eventually into a data warehouse, and they have massive ones. Unfortunately, many governments do the same. And we will cover more of these topics in relation to the sales and collection cycle. And again, I have 2 chapters under that in your syllabus just for you to read from the Bodner and Hopwood book. I won't test you on those things separately. Again, I will only test you on these first 4 chapters and only the information which is covered here in the handout. Now, finally, chapter 4, transaction processing and the internal control process. Little introduction. Well, much of this chapter reviews the internal control material that we covered back in the first auditing course. So that means we can shortcut a lot of things. And by the way, in the book, from Auditing 1, I strongly encourage you to review internal control very carefully as you approach studying for the CPA exam. So this outline simply includes the additional features we need. Well, first of all, with the transaction processing controls. These may be divided into general and application controls. We should understand what both are. So general controls concern the overall environment of transaction processing. They affect the organization's entire IT environment. An auditor must be satisfied they're properly designed and operating before relying on application controls. Strong general controls are a necessary but not sufficient condition for strong application controls. So at the top of the organization, one must have strong general controls in order to have strong application controls further down, because in number 2, application controls are specific to an individual application. For example, specifically to the sales and collection cycle. Again, if there are not good general controls at the top of the organization, the application controls, in this case with the sales and collection cycle, just won't work because they don't have the backing of strong general controls. Now in B, general controls include the following. First, the plan of data processing organization and operation. One thing that we discussed back in the first auditing course, segregation of duties. And that is very, very important in business and for the CPA exam as well. And a key consideration in an IT environment is the separation of users of information from those in data processing. And data processing should be centralized. So in other words, centralized or one department in the organization. That way we have consistency and also experts in that department. And the following employees should be separated or segregated within data processing to maintain good internal control. First of all, programmers. They develop software. Second, systems analysts. There we have development of the general design of applications based on the analysis of users' needs. Let me just make a correction there. Then computer operators. They operate mainframe computers. It's extremely important that they not have access to detailed programming listings because that can allow them to go into programs and, well, make some unauthorized changes and perhaps commit fraud. Then a librarian maintains a depository of computer programs and documentation. Thus, this person is responsible for the custody of information assets. Then a data control clerk. That person's going to establish control over jobs and input data. It will include the quality of input, the completeness of processing, the reasonableness of output, just to make sure proper quality control is there. And those jobs could be tested on the CPA exam. They're quite easy. Then we also need general operating procedures, such as how to turn on the computer. Then equipment control features, such as making sure that we control equipment, we lock it up, we don't subject it to the elements, etc. Then equipment and data access controls that would include user authentication and having proper passwords. There are some examples of each in your book. I'm not worried about those examples. But just look at them on your own when you have a chance. Then application controls. They include input processing and output controls. There are examples of each in your book. Again, I'm not worried about those examples. Then processing controls may be divided into the following types, and these could be tested on the CPA exam. First of all, preventative controls. They act to prevent errors and fraud before they happen. So we would like to have strong preventative controls. It's better to prevent something from going wrong to start with. But then let's say something does go wrong. That's where detective controls come in. They act to uncover errors and fraud after they occur. And corrective controls. They act to correct errors. So that can help us in error correction. So that concludes the information from accounting information systems that I am concerned about. And again, the only information I will test you on. So thank you, and please let me know if you have any questions.